Greetings to the evaluator who's going to evaluate my presentation today. And first of all, I'd like to thank to Mr. Professor Dr. Muzame and the industry panel who are going to watch the throughout the videos. So now I'm going to introduce what's my topic of my FYP today, final year project. So my title of my final year project today is improvement of in-house device, which is called as betterment features to measure shear wave velocity of PEAT in PAHANG. So I myself, Srihari Gopinathan with the card metric number AA20071 with the supervisor of TS Dr. Youventharan Duraisamy. The background of this tale is actually the peat soil and other soils have the challenging parts in the compressibility of the behavior which can use for the construction, but they always avoid this kind of soil due to the instability, and then there are some sensitivity of the soil over here. So that's we need to do a proper testing before conducting or constructing the structure of any buildings over here. That's why we need some kind of an in-house device before we are going to do the lab testings. So the proper statement, every soil has its own value like G log shear modulus, and then which is can be calculated by S waves from the shear wave velocity. So this portable bender element will be usually at the soil lab. So it's a bit costly, and also so what's we going to do is we're going to do an in-house device which portably can check at the site on site with a budget. So going to the research question, first of all, the device is already developed by my senior Katie Lee. And then now what's my question? I need, can it connect to any devices like a smartphone, laptop, or like that? And when we see the device or calculate the shear wave velocity of graph with a naked eye, there sometimes could be a parallax error over there, or the device error or human error will be occur over there. So can we be reduced by using the device we are connecting to the betterment element? So overall aim of the betterment instrument is just to increase its features and get a best result from it, like a reliable one. So specifically going to my objective is to improve the data by connecting betterment to a device like a PC or smartphone with the help of a software, and then to reduce also human error when recording the data manual. So sometimes the, like I said before, parallax error or the device error like that, and obtain the reliable data by using any software we are going to develop. So these are the scope and limitation. For the scope, we need to study the create the bender element test, which is the device using internally, and then is it possible to measure the shear wave velocity of PEAT with a created apparatus, and then produce device finding the compare the earlier research has been published to study the year to complete and starting with the device collecting. So there are also some limitation because when you we go using, even though the device is conducted an on-site device, but it need to have a current supply over there. So it's the limitation over there. And then the value when we slightly different from a proper lab testing. After that, the internal tool may be not function, or the soil might be not peat. These are the challenges because we cannot identify the peat by naked eyes also. So since the study table also, uh, the bender element device is in the lab is very costly. So if we can go to a low budget one, we need to compromise some instrument on it. These are the things like limitation over there. So these are the example of literatures I've gone through. So usually I took literature the latest 5 years because every time every projects that are being evaluating or researching will be improvised day to by day, because even every second there will be any research conducted and there will be a new value on it. So it's better to use a recent 5 years papers to be researched. So these are the methodology how I conducted first. First, from the starting, need to do a pre-soil testing collecting. So we need to take the soil sample first. So on site, we will do a Macintosh probe test and 1 post scale and pH test to identify the soil value. And then when we take the soil to our place, we need to do a conduct a lab experiment also, like a moisture content, direct shape box, and these are the things which helps to identify what type of soil it is. And when we get the result, we need to compare it and then use the same sample to put in the betterment and need to compare with the lab test also. So by speaking to the my objective, I need to connect the device because betterment is already working. But it need to be done manually, even the calculation or reading. So my scope, can it connect to a device and can we output by automatically? So that's the thing of that. Okay. So these are the methodologies we are going to use. The apparatus and the signals are very easily explained and with the diagrams all. So it's the numbering will shows how it will be worked on the flows. Okay. This is the main part what I develop. If you see this, when I connect the device to the PC or laptop, it cannot be read automatically. So it needs to download the Hentech software 2xx2 versions, which is supported by the Betterment device via the my senior raised up. So if you see the first row at the up, it's the data we can get from the software. But after many failures, I develop a coding also from the data need to interpret it, and if you see that there's a wave over there, it's automatically interpreted from the transmitter and receiver waves also over there. So the peak will be taken over there, peak to peak, and then from there, if you see there the last, there will be an Excel sheet with the output of a shear wave velocity and then Gino shear modulus, everything what we need it will be in the Excel. So this is the result analysis from the guide. Okay, if you see at the left hand side of yours, you can see the manual reading of shear wave velocity, which is done by a naked eye by reading the data on the betterment device. First one is if the green color line is the Pekan's one, and then the blue is Maran, and the purple is Gabang's soil. From the naked eye reading, we can classify here as the Maran soil we get was clay. Initially, we thought it was peat soil, but when contact the result was compared and we was identified it was clay, and then the second one pecan is silt, and then the third one gambang was the peat soil we wanted. So if you see the graph also, after the 2000 velocity, you can see there's some gaps over there. So you need to be closer down because it's all going to be got errors inside it. So if you see at the right side, what the automatic reading of shear velocity, the data will be very near to the line, which means the errors are getting closer. And then if you notice that the peat is different, pecan clay and then silt of Maran, it looks similar compared to the manual reading and automatic reading. But peat soil, the graph automatically changed the shape of the graph. This is because the peat soil is very sensitive due to its void ratio, the water content, moisture content over this. Even when they're transporting the soil to the lab also, it will have changes on it. So it's because the soil is so sensitive, by getting naked eyes reading from the device manually, may have some this kind of inconsistent data. But from what the automatic software is, it will take the most peak transmitted wave to another peak, which is followed by the receiver wave. So the constant data will give a better result. For the next slide, you can see the result and analysis, which is plotted for the automatic data and the manual data. You can see there are many points at the near to the automatic data, which states that it's more reliable when we're using the automatic data compared to the manual calculated data. Even for the perfect data, to get the reference point as I put as y equal to x, there's this a slight difference only, 0.126 only. So the gradient which get from the automatic data is y equals to 1.180x, and then the regulation was 0.36, which is nearly to 1, which is a very good result compared to the very slow, very less dots which is nearer to the manual data. This gap also might be a small difference got from some kind of error, human errors we made, because the soil might be not compressed well, or the moisture content. Peat are very sensitive. So that's the thing, maybe the difference, a small difference over there, but it's a very good result compared to the manual data. So the work progress for my FYP2 and FYP1 I've set it there, and then from here I can ensure you that I've achieved my objective, which is to improve the data reading connecting to the betterment to the device by PC by using a help of software which is Handtech and the own coding I've developed. And then I've also reduced the human error which will occur like a parallax error or the instrument error by getting the obtained reliable data. And then followed by the conclusion, the device is already there and I've improved it well. So still there's been a limitation over there because the software I developed was a very basic software because of limitation of time. If the further come, they can improve the software more, and then even to get a live data is very good compared to the my one. So it can close down the graph which I said over there, the this one. If they get a live data, it will be more closer and will be more accurate. So this is the thing, the limitation and conclusion I would like to say, which can improve in the future. So these are the reference, and thank you for me. Thank you for lending me your ears. Have a great day ahead. Thank you.